Picture this: a needle piercing the sky, standing 828 meters tall. That's over half a mile straight up, a vertical city defying gravity itself. Building this titan required pouring 330,000 cubic meters of concrete, enough to pave a road 2,000 kilometers long. Imagine paving a road from Dubai all the way to Cairo with that much concrete. During its peak, 12,000 workers were on site every single day, a human hive mind operating at full speed. These workers, from 100 different nationalities, managed to complete a new floor every 3 days. For its foundation alone, over 45,000 cubic meters of reinforced concrete were used, weighing an astonishing 110,000 tons. That's heavier than a fleet of 747 jumbo jets stacked nose to tail. The tower's sheer height means its summit battles winds 15% stronger than down on the ground. This structure truly wrestles with the elements. It consumed 39,000 metric tons of steel rebar. Laid end to end, that steel could stretch a quarter of the way around our planet. Sleep tight, Earth. Its 57 elevators ascend at 10 meters per second, making them some of the fastest on record, reaching the 160th floor in a single minute. Supplying water to this dizzying height is another engineering marvel, requiring 100 kilometers of pipework to deliver 946,000 liters daily. Trying to carry your groceries up that many flights would be a workout. The building's peak electricity demand hits 36 megawatts, enough to power 500,000 100-watt light bulbs at once. The whole project, from digging the foundations to the final spire, took 6 years. 6 years to erect a structure on this unprecedented scale. The Burj Khalifa's bedrock rests on 192 colossal concrete pillars sunk 43 meters deep, like giants plunging into the earth. Engineers faced the immense challenge of building a stable base for what would become a vertical city, a task demanding extraordinary measures. Each of these skyscraper-sized columns is 1.5 meters wide, anchoring a staggering 500,000 tons of steel and glass. Just for this foundation, they used 45,000 cubic meters of specially engineered concrete, a formula boasting a compressive strength over 80 MPa, far exceeding typical construction standards. The desert sand itself presented a hurdle. It was too fine to form structural concrete. So the aggregates for this critical mix were actually imported from Australia, an 11,000-kilometer trek. Then there's the desert heat, often blasting past 40 degrees Celsius, which posed another constant threat because extreme temperatures make concrete cure too fast, risking cracks and a compromised foundation from the start. How did they manage? They chilled the concrete with ice and poured it only at night, keeping the internal temperature below 32 degrees Celsius. This prevented premature drying, ensuring the immense strength needed. Spanning above this forest of piles is a 3.7-meter thick concrete raft, spreading the tower's colossal weight like an unbreakable plate on the shifting sands. Building this foundation was an epic, record-breaking feat of pumping technology, pushing concrete vertically over 600 meters. All this, a monument built in just 6 years. "330,000 cubic meters of concrete, that's a mountain of material, went into building the Burj Khalifa, a monumental feat of human engineering against nature's harshest forces. Reaching dizzying heights meant confronting the invisible giant of the sky. Wind, a force that could twist and topple any lesser design. Engineers tackled this challenge with an ingenious Y-shaped plan, a structure that fundamentally confuses the wind. This unique triple-lobe design acts like 3 outrigger wings, dramatically increasing stability and reducing torsional twisting. Over 40 extensive wind tunnel tests on scale models proved its resilience, simulating thousands of hours of real-world conditions. These tests confirmed the Y-shaped slash's wind-induced motion by up to 25%. Furthermore, the tower's stepped and tapering form, with setbacks at each wing, scatters wind forces by an additional 15%. But it wasn't just wind. Engineers also engineered for seismic activity. The robust central core, with walls up to 1.2 meters thick, is the building's spine, capable of withstanding ground accelerations from moderate earthquakes. Dubai lies in a low to moderate seismic risk zone, but they planned for the worst, designing the structure to handle magnitude 5.9 earthquakes originating 50 kilometers away. This extraordinary resilience is partly due to the high-performance concrete used, rated up to 80 MPa, more than double the strength of typical high-rise construction. Despite this rigidity, some sway is inevitable and crucially designed for. The tower's topmost floors can move by up to 1.5 meters from their center in extreme wind events, a controlled dance. That sounds terrifying, but the building's sheer height and gradual movement make it almost imperceptible to occupants. You wouldn't even spill your coffee up there. We're talking about 330,000 cubic meters of concrete here, enough to fill 100 Olympic swimming pools, poured a world record 605 meters high. This push upwards was more than just design. It was a brutal logistical challenge, forcing us to invent new ways to get materials all the way to the sky. Imagine specialized concrete pumps, working under pressures up to 80 bars, acting like arteries, pushing over 40 cubic meters of material every hour. To keep that flow going, a single super-strong pipeline snaked its way skyward. Engineers spent months modeling fluid dynamics and pipe friction, just wrestling with how audacious this whole thing was. Beyond the concrete, 1.25 million tons of materials were lifted by 3 tower cranes that climbed the building as it rose, a steel ballet of staggering height. At its fastest, a new floor went up every 3 days, a relentless rhythm that demanded flawless coordination. This was humanity building its own artificial mountain, just tossing aside previous height limits. Over 12,000 workers swarmed the site daily during this peak, a temporary city forming around the rising spire. Even moving people and materials inside required innovation, with temporary express lifts zipping at 2 meters per second. Working at extreme heights, often in strong winds, meant strict safety rules and constant invention for rigging and fall protection. Then came the 24,348 custom-cut glass panels, meticulously installed by specialized climbing machines. A delicate, sky-high jigsaw puzzle covering an area equal to 17 football fields. Looking up, the steel spire just keeps going, lifted by internal cranes, a pure testament to this monumental effort. January 4th, 2010. That's the day the Burj Khalifa officially opened, soaring 828 meters into the sky. To put that in perspective, it's nearly 3 times the height of the Eiffel Tower. After 6 relentless years of work, the moment of truth had arrived. This wasn't just a building project. It was a global declaration of ambition, a testament to 22 million man-hours poured into a singular vision. News channels around the world broadcast the event, cementing Dubai's reputation. Think about trying to build a Lego tower taller than your house, but with actual steel and glass in the desert. The Burj Khalifa was more than a building. It was a bold economic statement, a cultural icon, and a symbol of human endeavor that captivated over 2 billion television viewers. Dubai suddenly became the main character, and everyone watched. Its tourism surged by 25% in that first year alone, drawing millions to witness this vertical city. The structure instantly placed Dubai on an unparalleled architectural map, its shimmering facade reflecting the ambitious vision of the UAE. Inside, 57 elevators ferry visitors at a speed of 10 meters per second, whisking them up 160 floors in mere minutes. Your local express elevator is still questioning its life choices. Housing 900 residential apartments and a 160-room Armani hotel, the Burj Khalifa is a vertical city capable of accommodating over 35,000 people simultaneously. This architectural triumph remains a global icon, challenging the very limits of human engineering and redefining urban skylines forever. It stands as a monument to impossible ambition, a new apex for human achievement. 330,000 cubic meters of concrete, enough to pave a sidewalk all the way to Cairo, formed the foundation for monumental human ambition. The Burj Khalifa didn't just rise. It joined a lineage of towering achievements, surpassing Taipei 101 and the Petronas Towers. It's a testament to humanity's relentless upward gaze, a drive we've seen across ages and civilizations. Over 12,000 dedicated workers poured 6 years of their lives into its creation, pushing engineering limits to build something truly extraordinary. More than steel and glass, the Burj elevated Dubai itself, transforming a desert landscape into a global symbol of innovation and a city looking toward the future. It was an audacious gamble, costing $1.5 billion, a bet on imagination that literally paid off by touching the clouds. Yet, like all giants, it demands immense resources, fueling critical conversations about sustainable urban futures. Within its dizzying heights, a vibrant micro-city thrives with over 10,000 residents and workers. Managing it feels like running a small nation, with 57 elevators whisking people up 828 meters. Imagine asking a friend to meet you when they're on floor 140 and you're on floor 70. Maintaining this colossus is a feat itself, cleaning 24,000 windows, a task that takes months, and ensuring its complex systems function flawlessly 365 days a year. The sheer volume of concrete, enough to fill 100 Olympic swimming pools, starkly reminds us of its material scale. The engineering required to pump concrete over 600 meters high demanded pressures akin to a submarine's crush depth. From the pyramids to today's megastructures, our species has always sought to build higher. This drive, this desire to push boundaries continues.